Unit 9, Day 2, Inscribed Angles and Inscribed Quadrilaterals. This will be part 1, which will be inscribed angles. Inscribed angles. An inscribed angle is an angle with its vertex on the circle. So take a look at B. The vertex here is on the circle with the two sides that are chords. So here's the vertex, extended or subtended out. This will be the chords. An intercepted arc is the arc that lies between the endpoints. So in blue, I'm going to mark the arc. The relationship between the degree of the inscribed angle and the intercepted arc is half. So the angle here, if it's 20, then the arc is 40. So the relationship is half is the angle and the whole is the arc. When we talk about an angle, the little m stands for the measure of angle ABC. If we start at A and go to B and C, the middle letter is the inscribed angle. That's the vertex. So we're really talking about B. Next, we want to talk about an intercepting diameter. So if you take a look, BC is a diameter, extends across the center of the circle. And if an inscribed angle intercepts a diameter, then it is a right angle. Remember, we talked about the middle letter being the inscribed angle. So the middle letter here is A. So here is A. And if I extend A to its endpoints and I connect that, that's half the circle. So what does that mean? That means that this whole arc is 180 degrees, which means, voila, this is a right angle. Okay, now we're going to talk about overlapping arcs. If two inscribed angles intercept the same arc, then the angles are congruent. And of course the arcs are too. So in that case, the measure of angle ABD is equal to the measure of angle ACD. We talked about the middle letter being the vertex and the middle letter also being the inscribed angle. So take a look here. B is going to be your inscribed angle here. And over here, C is going to be the inscribed angle. So I'm going to put a dot on B, and I am going to extend the arms or the chords. So the endpoints are A, and the other endpoint is D. So there you go, angle ABD. Now let's take a look at angle ACD. I'll put that one in blue. C is our vertex, and then we're going to go ahead and extend to the chords. Proper vocabulary is subtend. Now when you take a look at that, they share the same endpoints. So if they share the same endpoints, guess what? They share the same arc. And therefore, the arcs are congruent and so are the angles. So if you take a look at this, we have an inscribed angle. And if we extend the sides, we have an inscribed angle here. And if we extend the sides, we notice that they share the same arc. So if they share the same arc, the angles are congruent. So then how much is X? X is equal to 20. Let's go over a few things. If necessary, use colored pencils or a highlighter. And what you want to do is you want to mark the arc and the angle. It's almost like pizza. So the part in the bottom is the angle. And once we follow through to the endpoints and we connect it, that's the arc. It's like the crust on the pizza. Anytime you get to a problem, fill in as much information as you can. Write down the formula. The angle is equal to half the arc. I abbreviate it. A is equal to 1/2 A. You're going to see me write that over and over again. Check and see if there's overlapping arcs. If there's overlapping arcs, we're going to set them equal to each other. So let's go. When I look at this problem, it says find the measure of angle WXY. I'm going to focus on X. It is an inscribed angle, so the relationship is little a, which represents the angle, is equal to half the arc. Okay? And so what I want to do is, thinking about my little pizza, I'm going to go to the vertex, which is right here, and I'm going to extend the chords to find the endpoints. Once I find the endpoints, I'm going to connect the endpoints, and that's going to be my arc. So what do I have? I don't have the angle, but I have the arc, which is 62. So the angle is equal to half of 62, so the angle is equal to 31 degrees. So the angle is equal to 31 degrees. I look at the problem, I want to check out the angle Q. Where is angle Q? It is inscribed, and so what I want to do is I want to follow it out to the endpoints. So the endpoints are R. If I go this way, it's P. So when I connect R to P, oh my goodness, look at that. It's half of the circle, which is 180 degrees. It's an inscribed angle, so the formula is little a is equal to half the arc. Little a is equal to half of 180. So the angle is equal to 90 degrees. Well, we just learned a theorem there that if the arc or the endpoints go through the diameter, it's going to be 90. And there we go. We have 90. Every time we're doing the same thing. We're reading the directions. What are we looking for? They want the measure of angle K. When I look up here and I see angle K, it is an inscribed angle. I stretch it out to the endpoints. The endpoints are J and L. I go ahead and I connect J and L so I will know the arc that I'm looking for. I know I need the angle is equal to half the arc. Right now I don't have the angle and I don't have the arc. When you don't have the angle and you don't have the arc, some key numbers to think about is, can I use something dealing with 360? Is it half a circle? Can I use something with 180? Can I use something with 90? Well, I know that a whole circle from start to finish is 360 degrees. In this particular circle, it's showing me that from L to K is 65. And from K to J is 53. So can I find out how much is the rest of the way? So this is 242 degrees. Well, now I have my arc. This is 242. I can put it in my formula. The angle is equal to half of the arc, and the arc is 242. So the angle is equal to 121. So the measure of angle J to K to L is 121 degrees. This one doesn't ask for the angle. It is asking to solve for x. However, I see that the angle is an inscribed angle. So the first thing I want to do is write down my formula. A is equal to half of the arc. I am going to extend the sides so that I can see the arc, the intercepted arc that lies between the endpoints. So now let me go ahead and fill in the given information. The angle now is not a number, it is an expression. 8x minus 9 is equal to 1/2 of the arc, which is 158 degrees. So 8x minus 9 is equal to 79. We solve for x, and x is equal to 11. The next one, I read the directions to see what are they asking me to find, and they want the measure of arc AD. So let me figure out where arc AD is. Here is arc AD. What information are they giving me? They're giving me information about angle ABD, concentrate on the middle letter, and angle ACD, concentrate on the middle letter. So BABD, this is an inscribed angle. I see that when I extend the chords, it is connected to arc AD. When I take a look at angle C here and I extend the chords, it also is connected to arc AD. So if the arcs are the same, so are the angles. So what do we do to set this up? We set it equal to each other. Once we solve, we find out that x is equal to 5. But we're not looking for x. We're looking for the measure of arc AD. So what are we going to do? We are going to find the angle first. So 6 times 5 plus 26, and we get 30 plus 26, which is 56 degrees. So the measure of angle ABD is 56 degrees. So if this angle is 56 degrees, the angle is equal to half the arc. The angle is 56 degrees is equal to half of the arc, and we don't know what the arc is. If we multiply both sides by 2, the 2 cancels out. Multiply this side by 2, and A is equal to 112 degrees. So therefore the measure of the arc is 112 degrees. Let's find the error in this problem. This is not in your booklet. Find the error or state no error. When I look, I see a lot of inscribed angles. I see the angle A is inscribed. When I extend, the arc is DC. When I look at B and I extend, the arc is DC. The arc is 60. The angle is 30 because it's half. The arc is 60 and this one is 20. So what is the error? You got it. The error is angle B. Angle DBC should equal 30 degrees.